Okie dokie. So we're on to 604. Boop. Says the 10th. You'll see this on your plan. Please do it today if you can. If you can't, just enjoy it. Enjoy the week. Ooh, try a retake. You have three attempts. Try that retake. All right, binomial distributions. They are a bit different. I'm going to have to pause, check my work, and review in this video, and that's okay. The reason I'm going to have to pause and check is because I haven't had a second to review. Does that make sense? Often I review before I come to class with you guys so that I have that knowledge. Sometimes I misreview, misunderstand, or unprepared, like it doesn't work out the way I thought I had prepared it, and that's okay. We just dive in and fix it, learn what we need to. So here we go. Let's jump in and see how I do for the first binomial distribution, because this one does take some time for me to review each time. Dun, dun, dun. We got our coin flipping. The coin is flipped 4 times. X is the number of times it will land with a head up. What? Which statement is true about this situation? Okay. So let's go to our book. It's time to review. We're jumping into review right away. We're not even going to wait because we need to know what is the binomial distribution. So ideally, if this quiz you're like, whoa, there's a lot going on, stop, go to the lesson, work through the lesson, use your book. That's going to be a great way to see, hey, do these lessons really work for me? And I'm like learning and crushing this stuff. That's my hope. Learning is fun. It's hard when you're not interested in what you're learning. So the only thing I can say is to try your best, because you have to do it to graduate. You have to pass in order to earn those credits so that you can just be done with high school. But in the process of earning the credits, learning the material, and learning all that hard work, time management, dealing with different types of teachers, blah, 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 all that stuff, that process is why high school graduates do better than those who don't graduate high school. It's not just that they got a paper diploma. It's that they did all of the steps and juggled all of the different things they had to complete in order to earn that diploma, okay? And if you're watching this and you're like just barely scraping by and you're like, high school's really not for me, GEDs and after school, like there are other programs out there. But I would still highly recommend that you stick it out with us. You get in there, you do the work, and you just really, really hustle and try your best. I really, really recommend it because right now it's free. It's free. And a lot of GED programs are not free, or like another high school diploma program. They're not free, okay? My mom did not graduate high school, and she went back to night school to earn her high school diploma. You can do that as an adult. She was in her mid-20s going back to school. Because she didn't want her GED. She wanted her real high school diploma. And I'm proud of my mom. That was her choice. All right, here we go. A table or a graph can be used to represent outcomes of a variable that has a binomial distribution. So a variable has a binomial distribution if these things are true. There's a fixed number of independent trials. Okay, we have beaten this into our minds. Flipping a coin is independent. Every event has the same probability. That's the key idea behind independence. The probability doesn't change. I'm an independent woman, right? I gotta look up that song. I really do. I gotta look up that song. Independent. Okay, so far we're looking pretty good. It was a coin flip on our question problem. The outcome of each trial is a success or a failure. Okay, that one always got me. Our question is asking for heads. So if it's a heads, it's success. If it's tails, it's a failure. So that's it. So it is. It's a success, failure. Yes, no. Binomial. By two options. The probability of success for each trial is the same. Yep, it's independent. It's not going to change. Every time we flip, we got a 50-50 chance in this case. In this particular case, we have a 50-50 chance, a coin flip. So yeah, this is a binomial distribution. Let's go see what it says. Which statement is true about this situation? Fixed number of trials, 4 times. Success or failure, heads or tails. So it has a binomial distribution. The probability of success is 50-50 or 50% or 5/10. And the fixed number of trials is 4. Okay, let's look at some of the other ones. It doesn't because there's more than 2 possible outcomes. It does. It's the wrong success rate. You need to figure out the probability for your story. It doesn't because it's not constant. Okay, so again, use your notes in that case, just like I did, to help you think about it. Alrighty, boop. Cool. What was that one? Even. Okay, so even number is 50-50. That's why fixed number of trials. Over the next 4 days, X is the number of days it will rain. So it's still 50-50. No. Yeah, I was going to say. So look at this. I'm glad I looked at all of them. So you're welcome. Now everybody's variation was covered in this video. So pause it, go back when you get ready to take this just to check your thinking. Did you see how my face was like 50-50 chance of rain? That's not true. Right? And you should kind of get that kind of instinct about math and probabilities now as you start to read these stories. You should start to get a feel for what we would expect and how they work. And I instantly was like, no, that is not true. What are we, in Seattle? No. Okay. So the way that we predict weather, they do use probabilities and high-tech equipment with hundreds, thousands of measurements that is sent to computers. But it has a very crazy probabilities. It's not 50-50. It's not consistent. And as you know, we all have like a little weather prediction device on our phone. It's not always right. It can change pretty quickly too. So you can look that up, the prediction of weather, the history of the prediction of weather. Many people thought it was not true that you could do that. 1 second. I need to get this. All right. Sorry about that. I had okay. Never mind. All right. Sorry about that delay. Back at it. Back to this weather. Look up the weather. It's wild, the history of weather. And they thought it couldn't be done. And somebody was like, no, it can be done. We can predict the weather. But anyway, question 2, variation 2 here. Ooh, we're back into red, green, and purple marbles. Back into something familiar. We got this. In which distribution does the variable x have a binomial distribution? All right, so these questions, multi-select questions, are harder. So try your best. If you miss them and don't understand, just either submit a test correction, email me, or when I get back, we can talk about them and we can get those points back, okay? Thinking about our work is the best way to learn. So let's try it and think about it. Hey. All right. So the key ideas for a binomial distribution. Why is this one not checked? When a marble is selected 2 times in a row without replacement, X is the number of green marbles. Okay, when a marble is selected 2 times in a row without replacement. So we've talked about this. Okay, we've talked about this. If we do not replace it, it is no longer independent. We have changed the likelihood. There is only one Fluffy in Miss Lego head, and we draw. Ooh, we got a dice. We've changed the probability that we will get Fluffy. Oh, we don't put it back, right? We're now increasing everything we take out. We're increasing the chances that we choose Fluffy. But when a marble is selected 3 times in a row with replacement, it keeps it independent. So that's key. The with replacement is independent. Then the next thing is 3 times, 4 times, right? While they are both highlighted. All of that's fine because in a binomial distribution, you need a fixed number of trials. So this many trials. That's the key. Now let's take a look at this part. X is the number of green marbles. X is the number of green marbles. X is the number of green marbles. X is the number of green marbles that are not green. Okay, so that is green, success, not green, failure in these first 3. So that's how it is for a binomial distribution. You can figure out, it doesn't really tell us what the probability is, but we could figure that out because the probability of success would be fixed. It'd be green out of the total. How many green out of the total marbles? And failure would be the rest. The same thing would be true for the number of marbles that are not green. So not being green in this story is a success. and being green would have been a failure in this binomial distribution. Okay? Okay. All right, moving right along. Think about it. I don't know if that's going to help with the other variations, but we'll try. Assume that there are two trials where x equals 2, where x represents the number of successes. Okay. Which probability matches the probability histogram? Round the answer to one decimal place. Oop. Okay, sorry about that. So let's talk about this one. This is the one that I definitely have to review because we have some math to do. So we know this one. If you have this variation, great. Two trials, a fixed number of trials. Which probability matches the probability histogram? So the number of successes, 0, 3.2, and 0.4. None of those add or anything up to 0.2 because we have to do a little bit more of math. Okay, so this is now we're going to do some calculations, which the practice problems will help with. Okay, the practice problems will help you understand how this works. One second, right here. Here they are. See? I'll show you that in a second. Okay, so let's zoom in so we can talk about this in the mini lesson. Suppose the doctor is seeing two patients for a migraine headache. So that's kind of the story. The variable x can take on three different forms. So it's similar to our problem. The variable x could be 0, 1, or 2. Remember, if they're independent, which they are in binomial distributions, this is a requirement to use this process for a binomial distribution. Then you just multiply their probabilities. X equals 0 means that the medicine cue failed to work for both patients. So that probability will be failure, failure. There's only one possible outcome, that the first patient failed and the second patient failed. And then according to this, we'll go use our table to get this P failure, P or success, 0.3, 0.3. That's what our table is going to come in to figure out these numbers. X equals 1. This is a key thing. This is the one that I always have to review. Oh, yeah. We have two situations where that could be true. It could have worked in the first patient, but failed in the second patient. Or it could have failed in the first patient, but worked in the second patient. So this outcome, where it works once, is how you find it like this. You multiply them and add them. And in our situation, we have x equals 2, which means both successes. So success, success. So let's go back and read our table to try to see if it makes sense. Okay. Assume there are two trials. X equals 2, where x represents the number of successes. Okay, so there's two successes and two trials. So then according to this, we should be able, see, this was the one I always told you, this is going to be this one, the probability of success times the probability of success. So that's 0.4 times 0.04. Or do we end up, why do we divide? Oh, we need this. I'm doing it backwards. The probability of success times the probability of success is equal to 0.04, right? Does that make sense? Because this is our table that we've already done. This is the binomial distribution table. They've already done this math, not the other way around. Not the other way around. So in this case, this is the outcome of the two successes. The two successes equals 0.04. But the way they found that was the probability of success times the probability of success. Well, that's the same thing. So hopefully this helps. It's like the probability of success squared, because we're going to take the square root. Basically, the square root is helping us figure out what number, when the same number, when multiplied twice, equals 0.04. So let's take out our trusty calculator, and we'll do the square root of 0.04. Boom, there we go. See, I told you it's going to take me a second to review and think, what does this mean? Interpret it. And that's okay. All right. Hopefully that made sense. If it didn't make sense, let me know. So that's why this one is the right answer. And the story, we had to kind of really think about it. So quiz question 3 on 604, it's okay for it to be kind of hard. Okay? Let me know what you think about it. Use this to help if you'd like. So that's this right here. So you take a look. Success, 0.7 times 0.7 is 0.49. Well, that's x equals 2 is 0.49. So for us, x equals 2 was 0.04. So we have to undo that multiplication. Okay? Okay. All right. Moving back on. Question 4. 1 second. I have to answer another question. Be right back. Whew. Okay. Sorry about that. It's busy time. Some questions that I needed to answer right away. So I did. And now we're back at it. All right. Question 3 again was that table, the distribution, and trying to figure out the probability of success. So find what it equals, use your reference guide, and then work backwards to figure out the probability of success or failure, depending on your story problem. Okay, look, there's an example. No, let's see it for the next one. I think that was the example for this one. Question 4, variation 2. Ooh, we got a spinner. Okay, suppose the dial on the spinner is spun 2 times in a row. X is the number of times the dial lands on region B. Okay, so now think about just first, couple of things, couple of parameters for it to be binomial. Is it independent? Are spinners independent? Remember? Are they? Yes, spinners are independent, okay? They're independent. Each time you spin the spinner, it resets the probability. So that's key. Is there a fixed number of trials? Spun twice. Fixed number of trials. Is it success and failure? Land on B, not land on B. Landing on B is success, not landing on B is failure. Failure management, if you watch Stephen He. Okay. And finally, the probability has to remain the same. Like they can't change, which is part of it being independent, okay? Which table represents the probability distribution for the table X? So it's spun. All right, so now let's try to make our own based on what we know. So they're in fractions. That's great. Remember X, it's spun twice. X is the random variable for the number of successes. So the potential, I want to give us some space, for our outcomes, we could either have, we spin once, we spin 2 times, we never land on B. We spin 2 times, we land on B. We spin 2 times, we land on B both times. One of the times we land on B. That's what it means. So we need to figure out the probability of success. Well, the probability of success is the probability that we'll land on B. One-fourth? 1B out of 4 total oh my goodness, 4 total possible outcomes, A, B, C, or D. So the probability of success is 1/4. What's the probability of failure? Failure management. 3/4? Right? A, D, and C are failures. They didn't land on B. Because our story is spinning the spinner 2 times. Success means landing on B. Here's our binomial distribution. It lists the number of successful outcomes. So if it's 0, we will have the probability of failure times the probability of failure because they're independent. So you just multiply the probabilities. So that's 3/4 times 3/4, which is 9/16. Okay? This is the probabilities. We'll go down here to successes because it's easier, right? The probability of success times the probability of success. We have 2 spins that land on B. So it's 1/4 times 1/4. We have a 1/16 chance. Okay, so here we can be clever. We can do something fancy. We can be like, well, I know probabilities, even in this, need to add up to 1. So 9/6, is that true? Yeah. 9/16 plus 1/16 tells me that 6/16 should be the final outcome. but let's do the math to see how we get to there, okay? So remember in our book, right here, we have if we get one spin that lands on B, we multiply the success times the failure, or the failure times the success, and you add them together. So in our case, we're going to have 1/4 times 3/4 plus 1/4 times 3/4. Well, that becomes 3/16 plus 3/16 plus 3/16, which is equal to 6/16. Dun, dun, dun. So that's what we're looking for. Notice that might be simplified to 2/8. No, 3/8. Okay, so let's go try to find that over here. 9/16, 3/8. We can kind of see it. And then it should be 1/16. Hey, come on, scroll. There you go. Hopefully that kind of made sense using our book. I took some time to review, answered some questions of teammates, and then jumped into here, okay? All right, we're almost done. Think about how this is working for you. Practice, practice, practice. Practice was one of the ways you guys said help you learn, some of you. The truth is, practice helps all of us learn no matter who we are. We're into basketball. There you go, sports fans. And sports tracks stats like crazy. Your sports data is important. It's very important. In all games, all fields, your statistics are tracked. People do this. People bet on you based on your stats. You get salaries based on your stats. So anyway, let's think about this. This basketball player's probability of making a free throw is 90%. So that's not Shaq. Do you guys know Shaquille O'Neal? I don't know if he's been out of the game for too long. No way. Anyway, he wasn't great at free throws. All right, when the player makes 2 free throws in a row, X is the number of free throws made. Oh, of course, I have to give you a confusing one. Okay, so let's kind of enter your answer as a decimal in the box. Okay, so what is P equals 2? Probability of making a free throw is 0.9. When a player makes 2, so 2 in a row, X is the number of free throws made. I think they're just saying that he is making 2 shots, so he has the possibility of making 0, 1, or 2 baskets. Does that make sense? So the probability that X equals 2 should be the probability of success times the probability of success. That's what it should be. So it should be that simple. When we scroll down, it should be, that should be times 0.9 times 0.9. Does that make sense? In our story, this player is going to shoot twice. X is the number of free throws made. What is X equals 2? Well, it's the probability of success and the probability of success because he's shooting twice and making it is a success. So it should be 2. Okay, so it should be this. So that should be 0.81, but we can check it in our calculator right here. 0.9 times 0.9, 0.81. Let's scroll down. Okay, that's it for 5 or 604 binomial distributions. Keep thinking about it. These come up again. You might see different notation later on in the future, but you've got this. So interpreting binomial distributions till we get over to our next lesson, which is the continuous random variable. That will be actually in a little bit. We have a discussion to go talk about. So 605 is a discussion. So please participate in that discussion the best you can. It's not graded. It's really just an opportunity to share your thoughts and what you see happening all of a sudden when we start actually doing these experiments versus what we say the probability is.